In this video, we will study the reaction mechanism. The first topic of the reaction mechanism is inductive effect. Inductive effect. It says that permanent polarization of single covalent bond due to higher electronegativity of an electronegative atom bonded with carbon atom. So due to higher electronegativity of an electronegative atom, that should be more electronegative. So here we are taking CX bond, and it is saying that X is more electronegative than carbon. So shared pair of electron between CX single bond will be shifted towards X and will give rise to partial negative charge, while carbon will get partial positive charge. And this is indicated by an arrow, and this arrow is showing that carbon is less electronegative and X is more electronegative. Therefore, the shared pair of electron is shifted towards X. That's why X is getting partial negative and C is getting partial positive. If there are two carbon atoms bonded with X, one is directly bonded and first carbon is directly bonded, second carbon is indirectly bonded. The influence of X will be on both. So X will have negative and C1 will have one positive, and there will be a single headed arrow towards X, while X has the influence on both C1 as well as on C2. So C2 will have two partial positive, one because of X and next because of C1, because the shared pair of that electron of carbon, first carbon, has also been shifted towards X. That's why second positive charge is because of C1. If we are taking three carbon atoms in a chain, C1, C2 and C3, the X will get partial negative, C1 will get one partial positive, C2 will get two partial positive, and C3 will get three partial positive charges, showing that one partial positive, that electron is in shared pair of electron is in direct influence of X. In case of C2, the X is attracting the electron from C1 as well as from C2. That's why C2 is getting two partial positive. C3 is getting three partial positive charges. So this is because X is giving one positive charge, C1 will give another positive charge and C2 will give another positive charge. So there will be three arrows represented towards C2, and this shows that C2 gives one positive, C1 gives next positive and X give another next positive charge. And very important note to remember that beyond three carbon atoms in a chain, this effect becomes 0. What does it mean? The X has direct influence on C1, indirect influence on C2 and C3. So therefore, as we move along the chain, the distance of X will get increased, and beyond 3 carbon in a chain, the effect of X on C4 will become 0. That's why we say that beyond the 3 carbon atoms, the effect will become 0. In this way, there are two types of groups causing inductive effect. Number one, plus I having groups. Plus I having groups. This is the meaning electron donating or electron pumping group towards more electronegative atom. So they donate the shared pair of electron towards more electronegative atom. That is why they are called plus I having group, and they are alkyl groups. So we have methyl group, ethyl group, isopropyl group, and tertiary butyl group. The free single bond is showing that it is bonded with any more electronegative, that is X, which will attract the electron coming from alkyl group. So greater the number of alkyl groups, number of carbon atoms in alkyl groups, greater will be the property of electron donating property towards the more electronegative atom. So it has one CH3, it has two CH3, and tertiary butyl group has 3 CH3. So we can say that ethyl group has 1 plus I having group, isopropyl group has 2 plus I having group, and tertiary butyl group has 3 plus I having groups. That is, more the alkyl group or more the alkyl group bonded with carbon with which more electronegative atom is attached, more will be the electron donating property or more will be the plus I effect. So here methyl group has least electron donating property, that is, it has lowest plus I effect. Ethyl group we can also say 1 degree, isopropyl group we can also say 2 degree, and tertiary butyl group is 3 degree alkyl group. So that's why tertiary alkyl group highest electron donating property to the more electronegative atom, means tertiary butyl group has highest plus I having effect, isn't it? Now we will come to the applications of this plus I effect. Number one, reactivity of alkyl halides is directly proportional to the number of plus I having groups या plus I effect, isn't it? So greater the number of alkyl group, greater will be the plus I effect. So for this we are taking an example, reactivity of alkyl halides, so definitely towards nucleophilic substitution reaction that we will study later on. So CH3Cl has one CH3 and ethyl chloride has one plus I having group, that is CH3, and isopropyl group has 2 plus I having groups, tertiary butyl group will have 3 plus I having groups. That is why CCl bond of tertiary butyl group will be the most polar. So reactivity depends on the polarity of bond. So here an important note to remember that greater the polarity of CX bond, greater will be the reactivity, which is due to which is due to increase in the number of alkyl or plus I having groups, isn't it? So once again we are going to discuss about the reactivity of alkyl halides. Reactivity of alkyl halides is directly proportional to the plus I effect. That is, greater the number of plus I effect, greater will be the reactivity. Reactivity also depends on the polarity of CX bond, and CX bond polarity is directly proportional to the plus I having groups. Greater the number of plus I having groups, greater will be the polarity of CX bond and greater will be its reactivity. So in this way, methyl chloride will be least reactive, ethyl chloride will be more reactive, isopropyl chloride will be even more reactive, and tertiary butyl group butyl chloride will be the most reactive alkyl halides, isn't it? Next point, we will also discuss about it, that reactivity of alkyl halides is also directly proportional to CX bond length or inversely proportional to CX bond energy. So here we are taking CH3F, CH3Cl, CH3Br and CH3I. Alkyl group is same, but your halogens are different. So we will not decide the reactivity of alkyl halide on the basis of reactivity of fluorine. As we know that if we go for the reactivity of halogens, the reactivity of halogens is fluorine, chlorine, bromine and iodine. And this should come in your mind that fluorine is most reactive, the alkyl fluoride will be the most reactive. No, but here reactivity depends on the CX bond length. The bond length, CX bond length will be directly proportional to the atomic radius of halogen. So atomic radius of halogen may fluorine smallest size, chlorine largest size, bromine even more larger size, and largest size is iodine. This is the atomic radius, yeah, atomic size order of fluorine, chlorine, bromine. So this iodine is the largest atom. So Ci bond length will be largest. The bond length will have the order CF smallest, CCl larger, CBr even more larger, and Ci will be the largest bond. As we know that reactivity directly proportional to CH bond length. So longer the bond, lower will be the bond energy. That is energy required to dissociate the bond. Longer the bond, lower will be the bond energy and higher will be the reactivity. So in this way, reactivity order of alkyl halides is methyl fluoride is least reactive, then methyl chloride, then methyl bromide, then methyl iodide is the most reactive alkyl halide. Once again, I'm telling you that you can also think that fluorine is most reactive. So methyl fluoride should be most reactive. But this is the reactivity of fluorides. Fluoride, chloride, bromide and iodide. Yeah, fluorine, chlorine, bromine and iodide. But their reactivity of alkyl halides doesn't depend on the reactivity of halogen. Reactivity of alkyl halide only depend on bond length. If longer bond, more reactive. Longer bond, less bond energy will be the more reactive. And CI bond is longest bond, weakest bond and will have the lowest bond energy. That's why CH3I will be the most reactive alkyl halide. Clear everybody? Next point is your acidic strength of carboxylic acids. Acidic strength of carboxylic acids is inversely proportional to plus I effect. Inversely proportional to plus I effect means if plus I effect in carboxylic acid is more, then it will be the less acidic in nature. Like we are taking formic acid, another we are taking acetic acid, another we are taking propanoic acid, another we are taking isobutyric acid, isobutyric acid, another we are taking the acid having tertiary butyl group. So what is the role of these plus I effect? Plus I having groups. Hydrogen has I effect 0. The I effect is decided by the alkyl group. It is 1 CH3 plus I having group. It is larger plus I having group. It is even more large plus I having group. And in this last compound, highest plus I effect of alkyl group. Plus I effect alkyl group. So plus I having groups are electron donating group. And we know that acids are the compounds which when dissolved in water give H positive. It means this hydrogen atom which should be removed is having positive charge and oxygen is binding this hydrogen ion. So oxygen will have negative charge. Plus I having group increasing the electron density on oxygen, which will make the removal of H positive difficult. So more plus I having group, more negative charge density on oxygen. More plus I effect, more negative charge density on oxygen. Even more plus I effect, more positive charge density on oxygen. More plus I effect, highest plus I effect, then highest negative charge density on oxygen, which makes the removal of H positive most difficult, and this will become in this way weakest acid. Formic acid has no plus I having group. So that is why its oxygen has least negative charge density. And if the negative charge density is least on this oxygen because of zero I effect of hydrogen, it does not involve in electron pumping or electron donating. So this H positive will be removed most easily. That's why acidic strength will be highest in formic acid, lower in acetic acid, even lower than propanoic acid, and even less than in isobutyric acid, and it is fifth one. So here acidic strength will be highest in first one, lower in second one, and even lower in third, then fourth, then fifth. I think it must be clear. Acidic strength greater the acidic strength greater will be Ka, that is dissociation constant of acid, and lesser will be pKa, as pKa of an acid is equal to minus log Ka. So in this way, if we go for dissociation constants of acids, the first one has Ka1 greater than Ka2, greater than Ka3, greater than Ka4, while pKa will be lowest in strongest acid. The pKa1 less than pKa2 less than pKa3 less than pKa4. So here, what is the role of plus I having group? The plus I having group decrease the acidic strength of carboxylic acid by donating the electron to the oxygen. So as the plus I having group increase, that is bulky alkyl group comes, then oxygen will have more negative charge density, and it will make the removal of H positive ion difficult. The most difficult loss in the last one, because it has bulky group and it has three methyl groups, which will cause the donation of electron and increase the negative charge density at oxygen bonded with H very high. That is why removal of H positive becomes difficult and becomes weakest acid. So in this way, first formic acid is strongest and last one is weakest. And we also know that greater the acidic strength, greater will be the dissociation constant. So Ka1 greater than Ka2, greater than Ka3, greater than Ka4. pKa is equal to minus log Ka. As the Ka increases, then pKa value becomes decrease or decreases. So pKa1 will be least and pKa will be highest. I think you might have understood and you might have noted. Next, we are coming to the property using plus I having group, basic strength of amines. Basic strength of amines. So in gaseous state, basic strength is directly proportional to plus I effect of alkyl group. Like we are taking CH3NH2. CH3, your NH, CH3. CH3, N, CH3 and CH3. N has lone pair which will donate its electron pair. That's why it is basic in nature. And one more, we are taking ammonia. So we will compare ammonia with other alkyl. So plus I effect is increasing. Plus I effect is increasing. So in gaseous state, basic strength will be increased. This is 1 degree amine, NH, because it has NH2 group. It is 2 degree amine because it is NH group, and it is 3 degree amine because it has N bonded with 3 alkyl groups. So ammonia will be least basic because it doesn't have plus I having group. More basic will be methylamine, methylamine, and then more basic will be dimethylamine, and most basic will be in is trimethylamine. This trend is in gaseous state. So this trend is in gaseous state. So all should be in gaseous state, then they will show the increasing order. So tertiary amine will become so strongest base in gaseous state. But when we come to aqueous solution, this order will change. First of all, for methyl derivatives, in aqueous solution. Now we are studying the basic strength of amines in aqueous solution. The first is your ammonia, second is methylamine. We have taken third is your dimethylamine, and fourth is your trimethylamine. These all in aqueous solution. So this is 1 degree methylamine, then CH3, CH2, NH2, one more we are taking. So CH3, CH2, NH2 is 1 degree, and methylamine is also 1 degree. This is 2 degree and this is 3 degree. Here, point number 1. 2 degree amine, or say dimethylamine, is more basic than any primary amine. So we are taking here 2, ethylamine and methylamine. Reason, so this is 1 degree and this is also 1 degree. So here dimethylamine is more basic than 1 degree amines, because dimethylamine has 2 plus I having groups, which will increase the negative charge density on nitrogen of NH2 group more than ethylamine, even more than methylamine. So that is why, because two methyl groups will have more plus I effect and increase the negative charge density on NH2 group than primary amine or methylamine. Next question will be, dimethylamine is more basic than trimethylamine. So what is the reason behind it? While plus I effect in trimethylamine is more than dimethylamine, it has less plus I effect and it has more plus I effect. But plus I effect caused by 3 alkyl groups, plus I effect caused by 2 alkyl groups. But nitrogen atom of dimethylamine, nitrogen atom of dimethylamine is has less steric hindrance than 3 methyl groups of trimethylamine. What does it mean? What does it mean by steric hindrance? Steric hindrance to property, the property to hide either any bond or the lone pair of electron to cause donation. So these 3 methyl groups will hide this nitrogen atom or lone pair of nitrogen atom. So its donating property will become less. That is why it is less basic. So steric hindrance caused by 3 methyl groups will hide the nitrogen atom or lone pair of nitrogen atom to cause donation. That's why it is less basic, while your dimethylamine will become more basic because it is less hindered, less hidden. Nitrogen is less hidden, so it will be donated, the electron pair will be donated easily as compared to trimethylamine. Next point we will have that trimethylamine is more basic than methylamine, but less basic than ethylamine. Reason: because plus I effect of 3 methyl groups is more than plus I effect of 1 methyl group, and we are saying that ethylamine is more basic than trimethylamine, but plus I, that steric hindrance in 3 degree, that is trimethylamine is more than in ethylamine. So remember that trimethylamine is more basic than methylamine. The reason is plus psi effect is the dominating factor here in case of comparison between trimethylamine and methylamine. While when we compare the basic strength of ethylamine, the steric hindrance will be applicable here because it has C2H5 group which is having higher plus psi effect. So here steric hindrance will be dominating factor when we will compare trimethylamine with ethylamine. In this way, in aqueous solution, basic strength of methyl derivatives is CH3 whole twice NH, then CH3 NH2, CH3 CH2 NH2, then CH3 whole thrice N, then CH3 NH2, and least basic will be your ammonia that has no plus sign. So here when we will compare ethylamine and dimethylamine, it is more basic, that more plus psi effect, more basic because more plus psi effect, less basic because less plus psi effect. But when there is a comparison of ethylamine and trimethylamine, then here less steric hindrance and trimethylamine has more steric hindrance. And when we will compare trimethylamine and methylamine, the more plus psi effect will be applicable here and less plus psi effect will be applicable here, isn't it? So in this way, in methyl derivative, we again write basic strength order SA for secondary amine, PA for primary amine, TA for trimethylamine, tertiary amine, Ma for methylamine, and NH3 for ammonia. Next very important point, that aniline is less basic than any aliphatic amine, even than ammonia. So why? Aniline has formula C6H5NH2 and methylamine is having the formula CH3NH2 and ammonia has the formula NH3. We are saying that aniline is least basic. Ammonia is more basic and your methylamine, that is aliphatic amine, is most basic. Reason? Because methylamine has plus psi effect. It is electron donating group or pumping group, which increases the negative charge density on nitrogen of NH2 and increases the basic strength. While in case of aniline, lone pair is in conjugation with the benzene. So this is least basic because lone pair of electron is involved in resonance and negative charge density becomes less on nitrogen atom because this lone pair of electron is involved in benzene ring and it is called activating group actually. So that is why negative charge density on nitrogen of NH2 group of aniline becomes less and making it least basic. In this way, once again when we will write the basic strength order of methyl derivative of ammonia and aniline, the dimethylamine will be most basic, ethylamine will be less basic, trimethylamine will be even less basic, methylamine will be least basic, and ammonia will be even less basic, and aniline will be least basic because the electron density of on nitrogen decreases as it involves in the resonance stabilization, isn't it? So these are the basic strength in aqueous solution of methyl derivatives. Now when we take ethyl derivatives like C2H5 whole twice NH, C2H5 whole thrice N, CH3 CH2 NH2, CH3 NH2 and C ammonia, and at last C6H5 NH2. So here highest plus I effect is in trimethylamine, but dimethylamine, that is secondary amine, will be more basic as this ethyl group causes the steric hindrance and hide the lone pair of nitrogen, and in this way the donating property, electron donating property of nitrogen of triethylamine becomes less. So tertiary amine is less basic because of more steric hindrance. Then, but it is more basic than any primary amine. So then we will write the reason here. Here more plus I effect, here less plus I effect. When we will compare ethyl and methyl, so more plus I effect, less plus I effect. When we compare this aniline, so we will cause because of resonance stabilization, right? In this way, the ethyl derivatives have order SA, TA, SA, TA, PA, then Ma, then ammonia, then aniline, right? Then aniline. The aniline, because of resonance stabilization, the negative charge density becomes very less and its electron donating property becomes very less, and it becomes least basic, isn't it? Now we are having minus I effect. Minus I effect. So when we go for minus I effect, means electron gaining property. The electron gaining property, the more electronegative atoms or groups have more minus I effect. Here, when we go for more electronegative, more electron gaining property, more minus I effect. So now we are coming to the applications of minus I having group. Of minus I having groups. What is the role of minus I having groups? First one, acidic strength of carboxylic acids is directly proportional to minus I effect. Like for an example, we are taking an example of carboxylic acid halogen derivatives. FCH2, COOH, ClCH2, COOH, BrCH2, COOH, and ICH2, COOH. Electronegativity directly proportional to minus I effect. The fluorine most electronegative and iodine will be least electronegative. The greater the electronegativity, greater the minus I effect, greater will be the acidic strength. So here acidic strength order will be, it is very well understood that fluoroacetic acid is most acidic, chloroacetic acid is less acidic, bromoacetic acid is even less acidic, and iodoacetic acid will be the least acidic in nature because iodine has lowest minus I effect. So this is the application of minus I having groups. One more application we are taking of minus I having groups, some more electronegative atoms that carboxylic acid we are taking. ClCH2COOH, Cl2CHCOOH, CCl3COOH. Here, acidic strength is also directly proportional to number of minus I having groups. So here it has only one chlorine, so least minus I effect, and trichloroacetic acid has highest minus I effect. In this way, chloroacetic acid is least acidic, then dichloroacetic acid, then trichloroacetic acid. One more example we are taking formic acid, we are taking benzoic acid, formic acid, and acetic acid. So here you must remember that phenyl group is of minus I having group. Hydrogen has I effect 0 and CH3 is plus I having group. What does it mean? You understood that chloroacetic acid is least acidic because it has 1 minus I having group, chlorine atom, and it has 3 minus I having group, that's why it will be the most acidic. will have the highest Ka and will have the lowest pKa. When we compare benzoic acid, formic acid and acetic acid, the benzoic acid has C6H5 which is of minus I effect. Formic acid has hydrogen, its I effect is 0, and acetic acid has CH3, its I effect is plus I. The plus I having group decrease the acidic strength by increasing the negative charge density on oxygen, while minus I having groups increase the acidic strength by decreasing the negative charge density on oxygen bonded with H. So in this way, acidic strength order, benzoic acid is strongest acid, benzoic acid is strongest acid, and less acidic will be formic acid, and least acidic will be acetic acid. So this is about the application of plus I having groups. Next topic we will have electromeric effect, mesomeric or resonance effect, and other reactions. So we are stopping here. So please study well and do well.